Fourth tutorial on the calculus series. We have treated introduction to calculus, the limiting value of a function, and the derivative from the first principle. So basically in this tutorial, we're going to be discussing on how to derive the product rule and also the basic application. So first of all, I'm going to derive the product rule formula using first principle. Then we'll just go straight into application of the formula. Then at the end of the tutorial, it's advisable that you solve series of questions for you to master how to use the formula. Because if you are preparing for a CBT examination, it's essential that you work on your speed, and that determines on how well you practice the formula. So basically, let's start from our basic function. Now, let me take it from this perspective. When we say product, it simply means that we are dealing with the product of two functions. So when we say product, it means that we are dealing with the product of two functions. In first principle, you will discover that the first question that I solved was finding the derivative of y is equal to x raised to power n. Now, this does not involve the product of two functions. Now, let's assume that we have a function u and we have a function v. Let's say u is defined by x raised to power of 2 and v is defined by x raised to power of 3. So it means that if we are saying the product of the function u and the product of function v, this will give us x squared times x raised to power 3. Now, basically, because this is a very simple function, x squared times x raised to power 3 is going to give us x raised to power 5, which means if we differentiate x raised to power 5, okay, let me write this down. X raised to power 5. If we differentiate x raised to power 5, that's supposed to give you 5x raised to power 4. So now, we now want to define a formula whereby, because it's not all functions that you'll be able to use this approach, is because this follows the laws of indices and they have the same base. Now, how can we define a formula that is going to connect u and v together? So without following this exact process, and that's what we exactly want to do first. So instead of writing, if I define my y is equal to the product of function u multiplied by function v. Now, the first step in first principle is that we are going to add our change in functions to the both sides. For y, we are changing y. So this gives us y plus delta y is equal to, for u, we add change in u. This u plus delta u. For v, we are changing v. This is v plus delta v. Now let's open the brackets. This is y plus delta y will give us u into v plus delta v plus delta u into v plus delta v. So basically what we did here is that we use u to multiply everything we have here first. Then we now use delta u also to multiply everything that we have here. So this will give us y plus delta y will give us u times v. This will give us uv plus u times delta v. This will give us u delta v plus delta u times v. This will give us v delta u plus delta u times delta v. This will give us delta u delta v. Now, if we decide to take this y to the other side, delta y is going to give us uv plus u delta v plus v delta u plus delta u delta v minus y. So that's when you take the y from the left hand side to the right hand side. No, so now from here, delta y will give us this uv plus u delta v plus v delta u plus delta u delta v minus, now this y, don't forget our y is defined by u times v, so it means our y is the same thing as uv, because u times v is going to give us uv. So instead of writing y here, I'll substitute uv. So when we have uv minus uv, that's going to give us 0, so it's going to cancel out. So it means that delta y will give us u delta v plus v delta u plus delta u delta v. So the next step from this is that you are going to divide through by delta x. We are following the series of steps that we have on the first principle. So it means that if we divide through by delta x, delta y over delta x, so that's what we have at the left hand side, will be equal to u delta v over delta x plus v delta u over delta x plus delta u delta v over delta x. So immediately you divide through by delta x in first principle, you know that sometimes at the right hand side you might have some elements of delta x that can cancel out. But you can see that here we don't have anything canceling out. So it means that after dividing through by delta x, the next step is that you find the limit as delta x tends to 0 of both sides. If you don't like get the concept of what I'm saying, dividing through by delta x, you need to go and watch the series on derivative from the first principle. So under that series, we have explained each of those steps, why we are doing that, and the processes involved. So from here, if we take limit as delta x tends to 0 of both sides, this will give us the limit as delta x tends to 0 of delta y over delta x is equal to limit as delta x tends to 0 of u delta v over delta x plus limit as delta x tends to 0 of v delta u over delta x plus limit as delta x tends to 0 of delta u delta v over delta x. So limit of delta y over delta x as delta x tends to 0 is the same thing as dy dx. Now we know that this u is a constant here, so you can factorize the u out, and that is one of the properties of limit of a function. So for example, if you have the limit of, let's say, x tends to 2 of 2x, is the same thing as factorizing this 2 out and saying 2 limit x tends to 2 of x. So you can factorize what you have here out, as long as it is not the letter that your limiting value of the function is tending to. So this is the same thing as if we factorize out the u, we are going to have u. So limit of delta v over delta x as delta x tends to 0 will give us the v dx plus, we can factorize this v out, v limit of delta u over delta x as delta x tends to 0 is referred to as the u dx. So of course this automatically is going to be a non-divine fraction when delta x tends to 0. So this formula, the y dx is equal to u dv dx plus v du dx, is what you refer to as your product rule. So the theoretical definition is first times derivative of second plus second times derivative of first. And that gives you the theoretical definition for product rule. So now let's solve a question to expatiate more and you see how the application works. Now let's consider this example. We have y is equivalent or is equal to 2x plus 3 multiplied by x minus 2. Now, clearly, this is the product of two functions. The first function here is 2x plus 3 multiplied by the second function, which is x minus 2. Now, we have derived that if our y is equivalent to u times our v, from the first principle, our dy dx is going to give us our u dv dx plus v du dx from product rule. So basically what it means is that if we use the same concept, we are going to relate these two. This now becomes two equation, y is equal to u times v, and that same y is equal to 2x plus 3 x minus 2. Now you can take 2x plus 3 to be u, or you can take 2x plus 3 to be v, or you take x minus 2 to be u, or you take your x minus 2 to be what, v. And the reason why you can do that is because multiplication is commutative. So u times v is the same thing as v times u. So if I decide to say that let u to be equal to 2x plus 3 and v to be equal to x minus 2. So if u is equal to 2x plus 3, look at the formula. We need our u. We need the v dx. So since we have v to be x minus 2, the v dx simply means you differentiate v with respect to x. So we can find the v dx from here. The v dx will give us, if you differentiate x, you get 1. If you differentiate minus 2, you get 0. Now, if u is equal to 2x plus 3, our du dx will give us, if you differentiate 2x, you get 2. If you differentiate 3, you get 0. So our du dx is equal to 2 and our dv dx is equal to 1. So applying the formula from the y dx is equal to u dv dx plus v du dx. The y dx will therefore give us, our u is 2x plus 3 multiplied by the v dx, which is 1, plus our v, which is x minus 2 multiplied by the u dx, which is 2. So the y dx will give us 2x plus 3 times 1 will still be 2x plus 3, plus we are multiplying this by 2. So x times 2, this will give us 2x, minus 2 times 2, that will give us minus 4. The y dx will give us 2x plus 2x. When we collect like terms, this will be 4x plus 3 minus 4, that is minus 1. So our final answer will be 4x minus 1. So it means that when you differentiate y is equal to 2x plus 3 times x minus 2, you are going to get 4x minus 1. Now, because this is still very much basic, we can use an alternate approach, which is like the basic approach, the MS method, to solve this directly, because this is just involving the highest power that we can get from here is 2. When you say 2x times x, that will give you 2x squared. So it's not involving powers of 3, 4, 5, or let me say multiple powers. So that is where application of product rule comes becomes very, very important. So what I mean is that let's try opening the brackets from here. 2x times x, this will give us 2x squared. So 2x times minus 2, that will give us minus 4x. 3 times x, that will give us plus 3x. 3 times minus 2, that will give us minus 6. So this will be 2x squared minus x minus 6. So if it gives us just one function now. Now, if you differentiate 2x squared, you get 4x. Differentiate minus x, you get minus 1. If you differentiate minus 6, you get 0. So we use the same answer that you have here. So now don't get you might say that, okay, is this method not faster? The reason why this is looking faster is because we are just having the powers that we have here is not much. For example, when you are now giving something like, let's say 2x plus 3 raised to the power of 7 times x minus 2 raised to the power of 5, and you're now trying to use this approach. That is, you have to multiply 2x plus 3 by itself 7 times, then you multiply x minus 2 by itself 5 times before you now multiply the product of what you get from two functions. So though for this, we are still going to use application of function of function here, so which we are still going to treat as a subtopic. But no matter how you use function of function, you still have to use product rule to combine these and these together, and that is where the beauty comes into play. Also, when we get to implicit functions and we are given functions, let's say such as x squared plus y squared, let's say plus 63xy plus blah blah blah, and you are trying to differentiate these, you have to use product rule to solve that. So there is a wide range of the application of product rule, and it's very important for you. It's going to make your calculations very much shorter. Of course, you know that if you're in the CBT hall, you really don't need to write down the formulas. All you can have in your head is the theoretical definition, which is first times derivative of second plus second times derivative of first, and that makes your calculation much shorter. So let's take one more example so that we'll be done with product rule. Okay, so now let's consider another example. Let's say that we are given that let me use different letters in this case. Let's say m is equal to root n times n plus 2. Find dm dn. So we are given that m is equal to root n times n plus 2. We have to find dm dn. So we are going to use the same approach. So here we know that the y dx, because our fundamental formula is defined in terms of y and x, is defined by u dv dx plus v du plus v du dx. So if we are defining this formula in terms of m and n now, it means that this will become dm dn will be equal to u, our v, u dv dn. What I did here is that anywhere I see y, I'm changing it to m. Anywhere I see x, I changed it to n. So this will be u dv dn plus v du dn. So it means that this is what the product formula will turn to for this question. So now let's solve it. If our m is equal to, let me write that, m is equal to root n times n plus 2. So if we take this to be our u, we are going to take this to be our v. So from here, u is equal to root n. If our u is equal to root n, u is the same thing as n raised to power 1 over 2. So here, du dn is going to give us 1 over 2n raised to power minus 1 over 2. It means that our du dn will give us 1 over 2 root n. So same process, our v is equivalent to n plus 2. So what it means here is that the v, the n will give us, if we differentiate n plus 2, you're going to get 1. So our the dn is 1. Now, imputing the formula, our formula is dm dn is equal to u dv dn plus v du dn. So dm dn will give us our u. Our u is n raised to power 1 over 2. N raised to power 1 over 2 times the dn, which is 1, plus our v. Our v is n plus 2. N plus 2 times our du dn, which is 1 over 2 root n. So the n will give us n raised to power 1 over 2 times 1 will give us n raised to power 1 over 2 plus n plus 2 divided by 2 root n. So if you decide to collect your LCM here, a combined LCM here will give us 2 root n. So 2 root n times another root n, that will give us 2n plus n plus 2. So which will finally give us the m over dn to be 3n plus 2 divided by 2 root n. So which will be your final answer. So for this tutorial, this is where we are going to end for this tutorial. Catch you in the next tutorial, which will be quotient rule. See you there.